Welcome to our science episodes. Today we are going to continue discussing wave nature of light. Light behavior in different media. According to the ability of media to allow the light to pass through, they are classified into transparent media. It permits the light to pass through it like air and water. Opaque media. It does not permit light to pass through it like wood. Translucent medium, it permits only a part of the light to pass through it and absorbs the remaining part like flint glass. Now give reason for. An object can be clearly seen before and after putting it in a clear plastic bag. This is because air and clear plastic are transparent media that permit light to pass through them. A candle cannot be clearly seen when put behind flint glass. This is because flint glass is translucent medium that permits only a part of light to pass through it and absorbs the remaining. Light is known to travel in straight lines, and the thickness of these lines can be controlled. Get 4 cards, white paper plate, pieces of plasticine, and a light pen. Make an identical hole at the middle of the 3 cards and leave the 4th card without a hole. Fix the 4 cards A, B, C, D using plasticine on the white paper plate. The holes should lie on the same line. Allow the light of the pen to pass through the holes of the cards. You will find that a light spot can be seen on the last card. Repeat the previous steps after widening the holes in the cards, and you can observe that the light spot on the last card becomes wider. Again, repeat the above steps after moving one of the cards to the left. You will observe that the light spot on the last card disappears. As a conclusion, light travels through transparent media in straight lines, and the thickness of these lines can be controlled. Now we are going to discuss light intensity or brightness. In this activity, you will stand 1 meter apart from a wall in a dark room and direct the light towards the wall. Repeat the above step several times after increasing the distance between you and the wall. You will find that the light spot formed on the wall will increase in size with decrease in brightness as the distance between you and the wall increases. As a conclusion, the light intensity on a surface decreases with the increase of the distance between the source of light and that surface. We can define light intensity as the amount of light incident normally onto a unit area of a surface in 1 second. And we have also here inverse square law of light, and it states that light intensity of a surface is inversely proportional to square of the distance between the surface and the source of light. Here is the relationship between sound intensity and square of the distance between the light source and the point. It is inversely proportional. Now let's talk about factors affecting light intensity. Number 1, strength of the light source, and of course it is direct proportional. The distance between the light source and the surface. This relationship is inverse proportional. Can you say what will happen if the distance between the light source and the surface is doubled? In case the strength of the light source is constant, the light intensity will decrease to 1/4 of its value. And what will happen if the distance between the light source and the surface decreases to the half? The light intensity will increase 4 times of its value. Now it's time for questions. Why don't we see impurities in black honey? This is because black honey is an opaque medium, which does not permit light to pass through it. What is meant by saying that flint glass is a translucent medium? This means that it permits only a part of light to pass through it and absorbs the remaining part. Therefore, objects are not clearly seen behind flint glass. Write the scientific term. Light intensity of a surface is inversely proportional to the square of the distance between the surface and the source of light. This is inverse square law of light. The amount of light incident normally onto a unit area of a surface in 1 second. Light intensity. Thank you. Dear students, thank you for watching and see you later in other science episodes.